Here.
Joe, is you?
Yeah, can you hear me?
Oh,
Yeah.
perfect.
Okay, sorry, I had a problem with my microphone. I'm going to be sharing my screen in a minute. Okay. Can you see my PowerPoint presentation?
Yes.
Okay, very good. Introduce myself. My name is Joe O'Connor. I'm going to be giving a discussion about the fourth compiler design that I've come up with. A little bit of background. What I primarily use Forth for. I don't really have much of a hardware background. I use Forth primarily as a DSL embedded in a larger application. So I've written the following DSLs: Creole Forth for Delphi Lazarus, Creole Forth for Excel, for JavaScript, Python, Perl, and C#. I have the interpreter, not the compiler for that. And this is the address of my various Forth projects. I have a bunch of others. You may have to hunt around a bit for them. So this is my development methodology. I import whatever version of Creole Forth I have into the application.
Sorry,
whether
Joe, sorry, can I ask you to actually run the presentation? Your type is a little small. It makes it quite difficult to read you on the screen.
Okay.
F5.
Okay, F5.
Mm-hmm. Don't sweat too much.
It's not work. Just let me start again.
Just present full screen.
I'm trying to.
It's slideshow. It's in about the middle, 4 from the left on the menu.
Yeah.
Or from the right, sorry.
Okay.
There you go.
Right.
Great. Thank you.
Okay. All right. Start again. What I primarily use Forth for as a DSL embedded in a larger application. These are the versions of Forth that I've written. So this is how I would use it. This is my development methodology. I import it into the application. So if I have a JavaScript application, I reference the JavaScript version of Creole Forth. And then I set up a set of primitives to handle the tasks necessary. So this is a two-step process. I define a subroutine that follows a specified interfacing convention. It's usually a method that takes a global property structure as an argument and returns nothing. I add a reference to the dictionary with the build primitive method, and then when enough primitives are available, start gathering into high-level definitions. So it's possible to use multiple copies of Creole Forth for the same application, each with a different vocabulary set, which can be useful. In some Forth, instructions can be defined in terms of assembly mnemonics. The primitives defined by Creole Forth play a similar role. So compiler design, it's a bit unusual. I have no state variable. Compilation starts by pushing the immediate vocabulary onto the vocabulary stack and ends with the popping of this vocabulary. Immediate words are simply words defined in the immediate vocabulary, which the colon compiler will always search first. The interpreter is used by the compiler to handle the compilation. So let me go into what I mean by that. So compilation steps. I have a routine called compile colon. It sets up a new Creole word definition. It populates the name field and fully qualified name field. That's the name field plus the context vocabulary. So if I define it in the primitive hello in the fourth vocabulary, its full name is hello.fourth. Using a loop, it does the following step: looks up each word in the dictionary, builds a triplet with the following information: name with context vocabulary, address, and compilation action. It places a triplet into the pad area. This is a simple list structure. The pad area contents are gone through one at a time and passed on to the interpreter. So words with a comp and PF action are compiled into the parameter field, while immediate words are executed. So exec zero words, comments are the only case of that now, are handled by moving the input stream pointer. Literals are handled by putting the literal handling code before the literal. So do semi, it pops the vocabulary stack and ends the compilation. Okay. So here are the possible compilation actions, the table. Comp and PF, this is a synonym for comma. It compiles an address into the parameter field. So this is what's going to happen most of the time. An execute compilation action takes an address as a stack argument and executes it. It's used to handle compiling words like compile if, compile then. Exec zero moves the input stream pointer. It's currently used for comments only, and literal, anything else that could not be found in the dictionary. So this is what pad looks like during compilation. So I have the definition, test one, if hello, else tulip then. So if it takes token 52 and has an execute action. So 52 is pushed onto the stack. It passes execute to the interpreter. Hello, that's token number 5. That's position 5 in the dictionary, or address 5, has a comp and PF action. 5 is pushed onto the stack, passes comp and PF to the interpreter. Else, token, 53. Okay, I got ahead of myself. Pushes 53 onto the stack, passes execute to the interpreter. Tulip as a token of 6, comp and PF, pushes 6 onto the stack and passes comp and PF to the interpreter. Then 54, execute, pushes 54 onto the stack, passes execute to the interpreter. So, all right, that's very straightforward, a one-to-one mapping of the compiler, but this is what ends up in the compiler, and you can see that it's dramatically different. Okay, this is the compiled definition in the parameter field. So you have 55, and that's 0 branch, and it has an immediate vocabulary. And so compile if with the execute action, it compiled the runtime code for if. So okay. So this is how the compiling words work. They're in the immediate vocabulary. The immediate vocabulary becomes available when the colon compiler pushes it onto the vocabulary stack, and its visibility disappears when it's popped off. Therefore, this vocabulary is already searched first. It won't be prevented from action by a word in another vocabulary with the same name. They're usually defined in terms of two primitives. First has a compile time action, the second one has a runtime action. So if is a primitive defined by compile if. It has code to look up the token of zero branch in the dictionary and compile it into the parameter field during compilation. Zero branch is a primitive defined by do zero branch and branches to the address of the following parameter field entry if false. If true, it just increments the parameter field to the next entry to execute. So the advantages of this approach are simplicity. The colon compiler can be defined in about 100 lines of code, depending on the base language. I think that's about how long it is in the JavaScript version. It eliminates the distinction between state smart and state dumb words. So another advantage is code reuse. The compiler is essentially using the interpreter to do its business. So here are my references. Any questions?
Just
Excuse
for
me.
clarity, what is an SDL? Just describe that concept a little bit.
The concept of, it's a domain-specific language.
Oh, DSL, yes, domain specific, okay.
That's how I use Forth generally. I use it as a macro language that sits on top of a regular application. So, for example, suppose I have a web-based C# project. I'll write a bunch of primitives in C# and gather them together, and then run them with the interpreter.
Okay.
So, or if I have a JavaScript application, I do that. I create some primitives, gather them into high-level definitions. When I have enough of them, I might need like 40 or 50 before I start doing that. So,
Okay,
my-
and in Excel specific, what I'm trying to get my head around what you're doing here. What are you trying to achieve in Excel doing this?
what am I trying to achieve? Well, I found it's very helpful in Excel I can set up a bunch of definitions. I can have them execute on in a single cell. So I've written a whole slew of applications, and they might do various things. Like, for example, I used one this morning at work. I use it to download one set of definitions. I used to get a set of statistics doing a SQL query, reaching into a SQL Server database and getting some counts. Then another one, I did an FTP task where I downloaded some data, scraped it, and then imported it into the spreadsheet. So
Okay.
having a DSL on top of VBA is very convenient, I found.
Okay, I'm asking that because what I have done at work, and it's just in VBA, was writing snippets of code to query and get data out of a SQL database. But I could see that one could use something higher as well, yeah.
Okay. Yeah. Thank you. I can also create like a menu-based system with tabs. It's very easy to set that up, and so I just click on a member of a list and then have it run the code which I've set up in a cell. So I might say do task 1, do task 2, do task 3 when you click on this.
Okay.
All right. So if you want, here's an example I have for JavaScript. Oops. Trying to get in there. Excuse me.
Joe, we are running out of time today.
Hey, I'm sorry. I'll come back later then, okay?
Yes,
Um,
no problem. We make another presentation in future. It was excellent. I am very interested to know more about your compiler. It's all okay?
Right.
No problem.
I'm going to stop sharing now.
Thank you very much.
Okay, great.
Thank you, Joe.
Okay, welcome.
Thank you.